To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. Now we are going to start the second chapter of this lesson. So in the first chapter, we learn about heat and temperature, warmness and coldness, and even we did an experiment related to expansion of liquids, right? And now we know that using this theory of expansion of liquids, we can make thermometers. So in this chapter, we are going to learn about thermometers. So thermometers. Now, first of all, we are going to do this very simple activity to see how we can make our own thermometer using a real thermometer. Let's see how to do this activity, children. So after explaining all these things, I'm going to show you all how to make this simple thermometer. Okay? A simple thermometer can be made and calibrated. The levels can be marked, okay? As indicated in the figure below. A small glass bottle is filled with colored water. Look at this one. This is the small glass bottle. We have to fill it with colored water. Now you know the reason to fill it with colored water without filling it with just normal water. Why? What is the reason? So that we can see the different levels very clearly when we use colored water. Right? A small glass bottle is filled with colored water, and the empty tube of a ballpoint pen is fixed into it. The same way we use the earlier experiment. Okay? A paper strip on which a scale is marked is glued to the tube. Right? You have to take a paper strip and behind the pen tube you have to paste that paper strip with which is marked like this. Okay, so here we have already labeled it. This is the real thermometer, paper strip, tube of pen, colored water, small glass bottle. Then you have right next to this bottle thermometer, right? This water bottle thermometer, right next to this one, you have to immerse another real thermometer, real bulb thermometer. Right? So when you consider this water bottle thermometer, this water bottle can be considered as the bulb of the thermometer. Therefore, when you fix these two things, this real thermometer and this water bottle thermometer, these should be aligned with each other. Right? Bulb should be immersed in water. So then what you have to do is, after setting the apparatus like this, you have to provide heat to this entire setup, this big water beaker. Right, children? The bottle thus made is dipped in a beaker of water and the beaker is heated slowly. The entire setup is heated slowly. Right, then what will happen, children? When you heat this water gets heated up. Accordingly, heat is transferred from this big water beaker to the small glass bottle as well as the bulb of the real thermometer. Right? Then this bulb and the small glass bottle also will get heated up slowly. Right? Now, you know what happens when this colored water bottle gets heated up. What happens? Because of the absorption of heat, the liquid volume expands. Therefore, the volume increases. You can see the liquid level goes up through the pen tube. Okay? Right. A mercury thermometer is dipped in the beaker of water. When the water is being heated, the temperature rises and the colored water column in the pen tube goes up. Right, children? The position of the upper end of the colored water column is marked on the paper strip for some temperature readings indicated by the thermometer. So this is how we can do this. So let's consider if this is our real thermometer and if this is our water bottle thermometer. If this is the capillary tube. Now let's say initially you can see before heating up the entire setup, you will be able to see the level of that mercury level at a certain point. We'll take a different color. So you'll be able to see the mercury level at a certain level. This one also you can consider initially. Without heating, you will be able to see the colored water level at a certain level. Right? So we can come to a conclusion. Now let's say that this temperature we'll consider its room temperature. We'll simply consider it's 26 degrees Celsius, so 25 or 26. So before heating up, when you consider these two thermometers, right, this is water bottle thermometer, our simple thermometer and the real thermometer, when we consider the initial levels of the liquids, this one is calibrated, this one is not. But we can consider from the beginning of this water level, we can consider this one is also 26 degrees Celsius. This is where we are going to start from. We can consider as they are at the same level without heating under the same condition, we can consider now they both are the same temperature. So the temperature we can check using the real thermometer. Right? Then what you have to do, when you heat up this entire setup inside another water beaker, you will see these temperatures increasing. Let's say that at one point, if this temperature increases up to, let's say 30, so you can consider at the same time, when this one's temperature also increases up to a certain level, let's say at one point this will be 30, at the same time, this also we have to consider it's also as 30. Right? So we are going to calibrate this bottle thermometer according to the real thermometer, according to the way the mercury column increases. But remember, this is not exactly the same because here we are using two different liquids. Right? When we use these real thermometers, there are different liquids like mercury or alcohol is filled in the bulb of these thermometers. But here we are using water. So the way that they rises up and falls down is different. But for the time being, just to make our own thermometer, we are going to consider it like this. Right, children? So the position of the upper end of the colored water column is marked on the paper strip for some temperature readings indicated by the thermometer. The relevant temperature also should be indicated at the mark. Right, according to the rise of this mercury column of this real thermometer, you have to mark our simple thermometer as well. So when we do this experiment, you will understand this better. After marking several temperatures on the paper strip, a simple scale can be made. Okay, so we know like where the beginning, several temperatures we can mark accordingly. The water bottle thermometer thus made can be used to measure unknown temperatures in a short range. Why short range? Right, here we are using a pen tube. The size of the pen tube is shorter than the real thermometer. So if we can find a longer tube, we can increase the range that we are going to, temperature range that we are going to measure. So here you can get an approximate value, not the exact value, we can just get approximate value. We'll do this activity to understand this better. Right, children? Now we are going to make our own thermometer, a simple thermometer. Right? Now look at this setup, children. You all can see here the laboratory stand. Using the laboratory stand, I have fixed this real thermometer and this model thermometer. This is a simple thermometer. Right? So when we consider the real thermometer, there's a bulb. And when you consider this bottle thermometer, this tube is our bulb. Okay, you all can see this tube is filled with a liquid. And you can consider this tiny tube fixed to this one is the capillary tube. Okay, children? And both this bulb of the simple thermometer and the bulb of the real thermometer, both are immersed in water. Now using this real thermometer, we are going to calibrate our simple bottle thermometer or bulb thermometer. So when you consider this simple thermometer, this is not exactly correct, but we can get an idea how to mark some important temperatures using this type of bulb or simple thermometers. Okay? Right. So as both the bulbs in the real thermometer and the simple thermometer, both the bulb parts are immersed in water. Now you know that we can read the temperature of the water at this moment, right? So we are going to first read the temperature using the real thermometer. Check whether you can see the temperature, children. It's about 25 degrees Celsius. You all can see clearly. You can see the mercury column there. Okay, children? So at the same time, when you consider our simple thermometer, you all can see through this pen tube that colored water level is at a certain level. It is this level. Right. Okay. Now, according to this level of the water will also rise up. Right. Now here at the moment the temperature is 25 degrees Celsius. Right, children? So we can consider that this level of our simple thermometer is also 25 degrees Celsius. So accordingly, now we are going to supply heat to this water, and when the water gets heated up, you will see both the liquid levels, here the mercury level, here the colored water level will increase, will rise up. So then we are going to, according to the rising of this mercury column, we are going to mark the certain temperatures of this thermometer that we made. Okay. So this one is 25 degrees Celsius, initial temperature. Right. The first temperature, initial temperature of water. Right. Right. So I lit the spirit lamp. Now water is getting heated up slowly. Okay. Observe very carefully how both the liquid levels rise. Okay. So we mark 25 degrees Celsius. Now what is the temperature according to the real thermometer? It's still at 25. When it comes to 30, we will mark it again. So observe carefully, you will see it slowly increasing, okay? Right, children. Now the temperature using the real thermometer, if you observe the temperature, it is 30. So at the same time, you have to mark what is the second level here. But according to this one, it does not rise up that fast. Level did not go up that fast. Therefore, it's somewhere little above. That line should go a little lower too. When you compare this water level with the mercury level, water level rises up very slowly, okay? Now the temperature is about 35 degrees Celsius in the real thermometer, but I'm not going to mark it in our simple thermometer because it did not rise up that much, right? So the lowest line we marked was 25 degrees Celsius, then 30 degrees Celsius. I'm not going to mark 35 or even 40. Let's wait till it gets to 45 and then we'll try to mark it, okay? Right, children. Now the temperature of the real thermometer is 45 degrees Celsius, right? So here, which means we can consider that this can be considered as this level, as 45 degrees Celsius. Right, children? So there's not much difference, okay? This is 25, this is 30, this is 45. So when you do this activity, you can mark these values correctly, okay? Right, children. Now look at the temperature of the real thermometer. It is 55 degrees Celsius. So we will mark accordingly. This can be considered our 55. Right, children? 25, 30, 45, 55. Okay? Right. So when you compare these two scales, now when you consider the mercury thermometer and our simple thermometer, you can clearly see the rising up of this liquid level is here very slow. Why do you think the reason? What do you think the reason is, children? Right? So when you consider water, water can hold up can absorb a lot of heat. Right? Therefore, in order to water to get expand, it takes a longer time than that of this mercury. Mercury is a liquid metal. Right? So it gets heated up faster and accordingly it expands faster too. That is one reason. And at the same time, when you consider the diameters of these two tubes, so when you consider the diameter of this capillary tube in the real thermometer, it's so tiny, right? It's very, very thin. But when you compare the real thermometer, now we can consider this empty pen tube is our capillary tube of the simple thermometer, right? So when you compared it with the real thermometer, this one's diameter is way more higher. That is why even though a little increment of the liquid, we cannot see very clearly. Okay? Right. So observe carefully. The temperature reading of the real thermometer is 65 at the moment. So we will mark that one as well. So this is 65. Right, children? So 25, 45, 55, 65. Second one is 30. So you can clearly see that it's not exactly same to this one, but using these type of simple thermometers also we can get a rough idea. So when you make your own thermometer like this, you can simply mark certain temperature. So if you wait till the water boils, we can even mark. Now water boils at 100 degrees Celsius, right? So when this goes to 100, according to the rising up of this liquid level, we can even mark where the boiling temperature of water is too, right? So for that one, you have to wait for a longer time period in order to mark all these levels. Okay, children? So I hope you got a better understanding on how to make your own thermometer. Right, children? So you observe that experiment. I think you got a better understanding on how to make your own thermometer, a simple thermometer using a colored water bottle. Right, children? So we'll move on to the next. So we have this assignment to do. Mention the shortcomings of a thermometer as mentioned above. Right? So here, when we were doing this activity, I explained you certain things. Now, even earlier, I explained you all when we can use only because we are using a pen tube, we can measure only using this simple thermometer, we can measure only a temperature of short range. Right? So that the reason is because we are using a pen tube, which is short. Okay, children? Therefore, we can't, in order to increase the range, we have to use a longer pen tube. What is the other one, children? So when you compare these two thermometers, our simple thermometer and this real thermometer, so the real thermometer contains a capillary tube, a very, very thin or very tiny tube. Right? The thickness is very small. It's a very thin tube. Therefore, when the liquid level inside the capillary tube increases, we can see it very clearly because it moves up faster, right? Even a little bit of volume increase can be seen very clearly. Here what happens, thickness of the pen tube is higher than here. Therefore, the temperature range we cannot observe very clearly. For example, now when you consider this thermometer, temperature going from 26 to 26.5, and 26.5 to 27 degrees Celsius, we can see very clearly the movement. But here, because it is the thickness or the diameter is higher of this pen tube, what happens? When it goes from 26 to 27, you cannot see the difference very clearly. Right, children? You cannot see the difference very clearly because the diameter is high. Therefore, if we can use a thinner tube we can make it more accurate. Right, children? So we'll write some of these things. So mention the shortcomings of a thermometer as mentioned above. Give suggestions to overcome those shortcomings. So you can, I will explain you some of these things. You can write the other things by yourselves, okay? We can include them in a table. All right. Shortcomings. How to overcome. We'll write one of them. Temperature range is short. Due to the pen tube being short. So how to overcome? Using a longer tube. Using a longer tube. Number 2. We can write due to diameter thickness. Of the pen tube cannot observe the rise of the liquid clearly. So how to overcome? We can use a thinner tube. Using a thinner tube. Then we'll write one more example. One more example, children. We can write. So when you consider these two thermometers, this is the real one, this is the simple or the bottle thermometer. So we can consider what is the bulb of the thermometer of this simple thermometer. It is the entire bottle. The entire bottle acts as the bulb of the thermometer. But when you compare the bulb of this thermometer, the simple thermometer with the real thermometer, this bulb or the bottle is too big. Right? Therefore, it takes a longer time to heat it up, and then only it starts to give this temperature, provide this heat to the pen tube. Right? It takes a longer time to heat it up. Okay, therefore, you have to use a smaller bulb, smaller vessel here. If you use a smaller vessel, you can make it faster. Right, children? We'll write. due to the size of the bottle, it takes time to get heated up. Due to the size of the bottle, it takes time to get heated up. So using a smaller bottle or a vessel, something similar to the bulb thermometer, right? So shortcomings, I only wrote some of them, but you can think of the other examples too, right? Shortcomings and how to overcome them. Temperature range is short due to the pen tube being short. So you have to use a longer tube for that problem, right? Due to the diameter or the thickness of the pen tube, cannot observe the rise of the liquid clearly, right? Here using a thinner tube for as a remedy, okay? So due to the size of the bottle, it takes time to get heated up. What is the solution? Using a smaller bottle or smaller vessel as the bulb, right? So you can think and write off these type of example when you make. So when you do this activity by yourselves, you will find other difficulties too, right? Only by doing this activity, so even at school as a group activity, you can do this, right? So only when you do this activity, you will find what are the difficulties, what are the shortcomings, and how to overcome these shortcomings. Right, children? We'll move on to the next. So when we consider about the real thermometers, to fill the bulb, we use certain liquids, okay? We'll go through this. Mercury is used as the liquid of most thermometers used today, right? In most of the bulb thermometers, mercury is used, right? In addition, alcohol is a liquid used in the thermometers. Alcohol used in thermometers is colored. Why? What is the reason for using colored alcohol? Because normally alcohol is a colorless solution, right? So if we fill the bulb with a colorless solution, you cannot observe the rise of the liquid column very clearly. So for better observation, we normally use colored alcohol. So alcohol is a liquid used in the thermometers. Alcohol used in thermometers is colored for clear observation of the thin alcohol column. Right, children? So here, this is a mercury thermometer and an alcohol thermometer. You can see this is a colored alcohol solution and this one. Mercury, we don't have to color the mercury because it has its own color. It's silver in color. Right? Mercury is a liquid metal. So when it absorbs heat, it gets heated up faster, right? Okay, so when you consider the thermometers, it has the bulb. This is where the liquid is filled and it has a very thin tube inside this glass stem. It is known as the capillary tube and the scale is also marked, calibrated. Okay, children? So scales of thermometers. So what are the scales of thermometers? If you use thermometers at home, right, to measure your body temperatures and all, you know what are the scales. Most of the time, the thermometers that we use in our daily life are calibrated in two main scales, Fahrenheit and Celsius. But apart from this Fahrenheit and Celsius, so centigrade, there's another scale too, which is known as Kelvin. So when we consider physical quantities in science, all the physical quantities, like let's say that to measure temperature, to measure time, to measure length, there are different units, not only one unit. Right now here, when we consider the temperature, there are basically 3 units to measure temperature. Celsius, Fahrenheit and Kelvin scales, right? But when we consider these scales, these units, all physical quantities, only one unit. In each quantity, only one unit is considered as the SI unit or Standard International Unit. So when you consider the temperature, to measure the temperature, the SI unit or Standard International Unit used is Kelvin. Right, children? So there are several scales used in present thermometers. What are those? Celsius. Or centigrade is also correct. Centigrade. Fahrenheit. Kelvin. Celsius scale of centigrade scale, Fahrenheit scale, then Kelvin scale. Kelvin scale is used as the SI unit. But in daily basis, when we use thermometers, most of the time they are calibrated in either Celsius or Fahrenheit or both. Okay? So units of measuring temperature in each scale are given in the following table. Right? Temperature scale, Celsius. Symbol of the unit, degrees Celsius. Degrees Celsius. Right? Fahrenheit scale, what is the unit? Degrees Fahrenheit. Right? Degrees Fahrenheit. Kelvin scale, there's no degrees, it's just capital K. The symbol is capital K. Right, children? So the international standard unit or SI unit of temperature is Kelvin. You need to memorize this. Okay, children? The SI unit of temperature is Kelvin. Right? We move on to the next. So look at this table. You don't have to memorize any of these values yet, but some of these can be considered as general knowledge and try to memorize, because in the upper grades you might need to memorize some of these things, right? The equivalence between principal temperature scales is given in the following table for some temperatures. Okay, so in the first column it's given the type of temperature, boiling point of water. Now next we are going to learn about boiling points, melting points. Boiling point of water, what is the meaning of boiling point, children? Boiling point means the temperature at which the water starts boiling. Right, the water boils at a certain temperature. That temperature is known as boiling point of water. Right, and freezing point of water, what is the meaning of freezing point of water? When water turns into ice, there's a certain temperature for water to turn into ice. Right, so water turns into ice or water freezes at a certain temperature. That temperature is known as the freezing point. Mean temperature of human body. Right, the temperature of the human body. So all these three temperatures given in Celsius scale, Fahrenheit scale, and Kelvin scale. So boiling point of water, some of you might know, like these are generally we use. Most of the time these Celsius scales, some of you are familiar with. Boiling point of water, 100 degrees Celsius, which means water boils at 100 degrees Celsius. Right? And in Fahrenheit scale, it is 212. They are not equal, they are different scales. Okay? In Fahrenheit scale, it is 212 degrees Fahrenheit. What about the Kelvin scale? It is 373 Kelvin. Right? 373 Kelvin. You don't need to memorize these things yet. Freezing point of water, water freezes or water turns into ice at 0 degrees Celsius. Therefore, 0 degrees Celsius. So in Fahrenheit scale, that is 32 degrees Fahrenheit, which means 0 degrees Celsius equals 32 degrees Fahrenheit. Right? Kelvin scale, 273 Kelvin, which means 0 degrees Celsius equals 273 Kelvin. Right? And the mean temperature, human body temperature, 36.9 degrees Celsius. In day-to-day life, we consider it 37 degrees Celsius. Right? 36.9 is the exact temperature, but normally we consider it as 37 degrees Celsius. So the body temperature is 36.9 degrees Celsius. In Fahrenheit scale, that is 98.4 degrees Fahrenheit. Right? In Kelvin scale, it is 309.9 Kelvin. Right? So by going through this one, you can understand that there are different scales that we can measure the temperature with. They are not equal, there are differences. Okay, children? So we have completed this chapter now. So in this chapter, we learn about thermometers. Now you know how to make your own simple thermometer. And we learn about different thermometers, different liquids that we can use to fill the thermometer bulbs with. And we learn there are 3 scales that we can use to measure the temperature. What are they, children? Celsius scale, Fahrenheit scale, and Kelvin scale. So in the next chapters, we are going to learn more about heat and temperature and also thermometers.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.